in the meantime, you can see the answer to a question as you asked you're about the attendees. So currently we have half and half, some people from sales, some people from technical engineering backgrounds.
Okay.
So nice healthy balance, I would say. Okay, so I think many people have joined. So so before we start our webinar, I would like to welcome Mr. Herbert Blum among us. Thank you for joining. And currently he's at the fair EMV in Cologne. So we asked him previously to tell us a few sentences about this fair, what are his thoughts about it, and it might be interesting for some of you. And after it, we will start the main presentation. So, hello, Herbert, welcome. And if you don't mind, please tell us something about your location. Where are you now? What are you doing there?
Hello, everybody. Thank you for your introduction. As I said, my name is Herbert Blum, Product Manager from Schurter for EMC Components. And I'm here in Cologne attending the EMC fair, which is the leading EMC fair in Europe. And we have a booth here. Today is like the last day of the fair. It's like from Tuesday to Thursday. And it's let's say about 150 exhibitors, so 150 booths you have here, and you have workshops and seminars and forum speeches, which I usually also do, but not today or not this week at the fair. The trends here I learned, or what is new here EMC-wise, I saw that high currents, high voltage is a topic that's not complete new, but for example, first 1000 volt AC three-phase filter was announced here on the fair. 400 volt DC is a topic all the time for machines, for vehicles. Not so much in the automotive range, but it's more for heavy-duty machines. And what I found also a very interesting topic is that in one of the speeches here, they try to solve EMC problems with artificial intelligence. And I was told that the first spectrum analyzer has brought to the market with artificial intelligence integrated for, let's say, error or data analysis to help a bit to solve the EMC problems. It's also a topic about standards. We have so many EMC standards, and sometimes it's even for the experts. It's not easy to have to oversee all standards. And here, artificial intelligence can also help. But one problem that was mentioned is also the copyright of the standards. It's not easy because usually standards belong to IEC, you cannot share that over a ChatGPT or whatever. So that's it. That's probably, let's say, main topic. So higher voltage, higher current, a lot of DC application for EMC, and then artificial intelligence. Yeah, this kind of topics that we see here at the EMC in Cologne. So if everything is ready, we'll start. Okay.
Yes. I think.
And everybody can see my screen.
Not yet. Please share it again, as I have started the survey previously. So if you could just share it once again, please.
Yes.
Okay, perfect. I can see it, and that means that everyone else can see it. So the recording is on, and I think it is about time to start. So hello everyone, welcome to another SOS electronic webinar. Today we are joined by Mr. Herbert Blum, the EMC expert and product manager at Schurter. Today, during his presentation, he will talk us through about the portfolio of filters and windings, and he's here to discuss and advise you on how to apply them correctly in real designs. As previously, the questions will be answered after the main presentation. So in case you have any, please feel free to write them in the chat. And after the presentation, we will go through each and every one of them. So this way, the main presentation will be uninterrupted. As usually, the recording will be available on the socials afterwards, so everyone will have an access to it. So Herbert, thank you again. Thank you for the brief introduction and the interesting information about the fair. And the stage is yours. You can start your presentation. Thank you.
Thank you, and welcome to Schurter EMC Products. I will start right away. First of all, with a very short and brief EMC basics introduction, and then we go to products and applications. As you probably all know, the basis here in Europe for EMC is really the CE mark. And for this, we have a European directive. The latest is from 2014, which requires for any electrical equipment brought to the European market to have the CE mark. And one part of the CE mark is a declaration of conformity about electromagnetic compatibility. Now, what stands in this EMC directive is very basic, very simple. It just says any equipment brought to the market should not have too high emissions, electromagnetic emissions, and it should also have some sort of electromagnetic immunity. That's what it's all about. Of course, there are many more details written in all the EMC standards, mostly well known by IC standards, Senelec standards, or in other markets, maybe UL standards. Why is EMC more and more important? It has mainly to do with the technology change, with faster switching semiconductors, more powerful semiconductors that leads to technology change to be more convenient or to save energy. As you know, for example, we used to use transformers, mains transformers. Now it's all switching power supplies. Or we used to use light bulbs. Now it's all LED. Or we used to drive motors direct connected. Nowadays, it's all driven by frequency converters. Now, this all leads to, this very simple examples leads to EMC or electromagnetic interferences. And this noise has to be limited by some sort of EMC solution to fulfill CE mark and declaration of conformity to pass EMC test. Now, we have also EMC test labs. We have our own lab in Switzerland, in Germany, in China. We're building also up measurement capabilities in Italy. This can look like this here. What we do is we just do pre-compliance measurement. So we are not a fully accredited laboratory. We do pre-compliance test. As you can see here on that picture, this is a professional coffee machine standing on a wooden table with a copper ground plane on the floor. And then you see here the line impedance stabilization network and the spectrum analyzer here on top, who measuring the noise coming here, in this case, conducted via cable out of the coffee machine. And as an example, this could look like this graph here. On the left side is the noise over the frequency range from 150 kilohertz up to 30 megahertz over the limits, as you can see here or here. These are the limits here, according the standards. Here this is 55022 standard, class B, or with filter, the noise level should be much lower. It's below the limits. And that's fine. So this is on the left side, it doesn't pass CE requirements, and on the right side, it passes it, just with the help of a mains filter. Now, when we look on our product portfolio, we have power entry modules with filters. They all are based on an IC connector. Then we have one-phase, three-phase DC filters, and we have different winding goods in our portfolio. Now, let's have a look a bit deeper into that portfolio. We can say we have, for power entry modules with filters, we have the widest product range of power entry modules with filters available on the market. At the moment, 39 types of IC connectors in the range of 2.5 amp, 10 amp, 16 amp, all rated 250 volt max. It's clear, together with maybe fuse holders, switches, circuit breakers, voltage selectors. That for itself is not so special. You will find several suppliers having inlet with filters, but we have very special features. For example, we have power entry modules with V-lock cord retention, which we believe is a very safe and convenient cord retention, simple. Then, of course, we have standard and medical filters. That's not so special, but we also have high-performance filter versions. Over the last year, we brought out more and more high-performance filter versions. We have filters with integrated ground choke. I will come to that topic later. We have filters with ingress protection. That means they can be IP54, IP65 sealed, so waterproofed connectors. And protection class 1 or 2. Most of them are class 1, it's clear, with ground connector. Class 2 is without ground conductor. White color version, as you can see here on the picture, this is more for specially made for medical applications, where everything needs to be clean. Now, what's special here? A technical trend for sure is liquids, the protection or ingress protection that we need in certain application. As you can see here on the picture is one of our newest inlet filter here with the cord here. Can be used, for example, for industrial automatization, for robots, for food application where you have liquids, or medical. In medical standard, often is required to have some sort of water protection. Often the minimum is IP21, which is only drop water. But medical companies are really willing to pay a bit extra for extra safety. and then they prefer to have IP65 usually. We also provide 67. And this is one example here. This 5180 is, let's say, our newest inlet filter that we brought to the market last year. It's completely sealed all around here, IP67 and IP54 for the cord connection. It is class 1 or class 2. Class 2 is also qualified for medical 2 MOPP. This is a medical, according medical standard, 2 means of patient protection. Of course, this has all the certification for worldwide use, as you can expect from us. What we have also here is we have standard and high performance versions. This is a bit of a technical data. I will not read that all. It's just to give you an impression how it looks like. For example, class 2 is tested 5.6 kV. So it's really made for medical application with high insulation. A similar type is the DG12. It's a new inlet with circuit protection. So you have this sealed inlet with circuit protection here with a cover. It's also IP67. The rocker switch is recessed, so you cannot accidentally drip it on or off. And of course, we also have V-lock cord retention for this. It's also available in white color. This is then here, what you see here, a bit of technical data, but you see here, this version is not sealed. So this is like the standard version without seal around, so not waterproof version. We combine this inlet, waterproofed inlet, with a special V-lock cord set. What is visible is that it is blue. So the cord is black, but you have this blue knob here, and you have this blue sealing around here. So this is a sealed cord set, because only with this cord set you can reach IP54 for the cord connection under load. Another, let's say, a bit special topic we have is inlet filters with ground choke. Now, why do we do this? What can happen is, this is quite typical in the medical field, but also in the laboratory field, that you have one device here and you have another device here. Both are connected to the mains and also grounded to the mains, but they are connected via shielded cables. And it can happen that the ground impedance on one side here is different from the impedance on this side. And what you see then, and this is often forgotten or overseen in EMC measurement, it can happen that you have high frequency currents on the ground. And with this impedance mismatch and the connection of the two devices, I create a ground loop. And the ground loop is something you don't want. It's causing troubles. And we have seen in EMC applications that they try to solve problems with better and better and better filter, didn't help. But at the end, a small ground choke solved the problem. Really small choke, because the difference of impedance is very low. So one choke here, this ground loop is completely gone. It's very simple. And The good thing about having a power entry module with integrated ground choke, it's the easiest way to solve this problem because you cannot do anything wrong. Because power entry modules are placed on the exact best place where the power comes into the equipment. And we have the ground choke integrated exactly on the right place. You can also have, for example, an inlet filter here and have an additional ground choke on the ground conductor on the back. The problem is this will not work because the ground high frequency current will bypass this choke. It is blocked here, but it is everywhere. It is, for example, on the metal chassis or housing of the device. And this is connected to the filter housing. So it can easily bypass this ground choke. Integrate the ground choke. This is what works. So this is just the way it looks. This is a C20. That means it's a C20 inlet for 16 amp. It's the bigger inlet. But we also have the same version with 10 amp. This is a bit of technical data. As I said, 16 amp in Europe, 20 amp in US, according to the standards. And this is the way it looks. This is another power entry module with integrated ground choke with 2 fuse holders, especially for medical applications, because in medical application they like or they need to have double pole fuse holders. And they use, of course, also this ground choke to get rid of ground loops. For example, think about patient monitoring systems where you have several devices connected together and connected to a patient. It can be a real problem with ground loops. Now, when we look on single phase filters, we have also here a wide range of single phase filters. Let's say general single phase filters in the range up to 60 amp. Most of them are rated 250 volts. Some have higher ratings depending on application. Most of them look exactly like this here in the middle, for example. This is the typical chassis mount single phase filters made for a wide frequency range with metal housing, somehow mounted into the equipment. That's fine. We also have some, but only a few block filters on the printed circuit board, or we have rail filters that go into the control cabinet. Of course, here it's a bit the same. So you have different types, different dimensions. You have single stage, double stage, triple stage filters, standard or low leakage current filters. We also, and we are one of the only one having single phase filters with integrated ground choke as well. It's the same topic as I explained just before for the power entry modules with filters. We are the only one having protection class 2 single phase filters. This is especially made for medical application where protection class 2 is required. For example, according standards in home care equipment or in ambulances. Of course, most of them are chassis mount, quick connect terminal, things like that, but you can also have with wire leads or PCB terminals. That's it. Now, what's a trend here? Of course, control cabinet. Now, when you think about a control cabinet, what is important is how much space you use here on the DIN rail. So we decided to do a slim version. The old control cabinets filter were quite wide, about 60 millimeters. Now this is 25 millimeter wide. So slim, this is what counts. What else did we do? We found out people don't like screwing in control cabinet. They like these cage clamps where you can push in wire. Very simple, very quick. So we have cage clamps here. And we integrated also into the filter over current protection. As you can see here, here's a little thermal circuit breakers, but you can also have fuse holders, and over voltage protection is also integrated. So it's like all in one, very compact. As you can see here, of course, we have like, it's a two-stage filter, standard and medical version, with varistors here for over voltage protection. And as I said, 25 millimeters wide only. So it's a good filter for control cabinet. It has one point here, or one, let's say, weak point. It has a plastic housing. Now, most filters we use metal housing for better ground connection. That's just a fact. Metal housing is EMC-wise always better than a plastic housing. That's just a fact. But we decided to have this slim form, to use a plastic, and we have here integrated a printed circuit board, and one side of the printed circuit board is only ground. So we have a bit of a ground, but it's not the same as a proper metal housing. But the reason why we did this is because the control cabinet usually is also made of a metal housing. So it's a metal enclosure. So EMC-wise, it should be fine. And here also the three versions without overcurrent protection, with fuse holder or circuit breaker. Then we made, as you can see, for example, most filters that you see are one or two stage filters on the market for single phase applications. And we see a tendency to have higher performance because of the faster switching semiconductors. The noise level gets higher and wider in the frequency range. Therefore, we decided to do better performance in compact housing. And this is just one example here. This is a bit of technical data. It's a two-stage filter up to 36 amp. That's for itself not so special. But what is special is here really is the performance. Because when you compare this with the standard filter, let's say, as we also have, as you can see here on the black curve, the black one shows you the performance here in asymmetrical or in common mode of a standard filter, two-stage with ferrite cores. And the blue line is the FMBB EP with nanocrystalline cores. The good thing is these two filters have exactly the same dimensions, but the performance that I gain here, especially at the lower frequency range, is really massive. In differential mode, what counts here are the X capacitors, and it is not that big difference. We have a bit of bigger capacitors in the FMBB EP version, So you see also here we gain something, but overall or in the higher frequency range, the difference is not so big. Now, my general advice out of our experience is that, for example, you have here an example of a single stage filter that provides you maybe something like 60 dB of maximum attenuation, as you can see here. Maybe 60 dB, something like that. Now, this is good for maybe 50 to 60% of all application. This is good enough. For example, if you have switching power supplies, things like that should be good enough, or one motor drive should be good enough for that. But it can be that you have you see more noise at the lower frequency range, maybe what, let's say 100, 200, 300 kilohertz, somewhere here. Maybe this is not good enough. Then we can use a dual stage filter, and then we get about 80 dB of attenuation here in the middle frequency range. That's good, and we also get better in performance here in the lower frequency range. Conducted measurement starts here at 150 kilohertz, and it goes up to 30 megahertz. So it's this range here in the middle. And here it performs quite well. Now, this is one stage, two stage, as I said, 80 dB. Is good for about, probably with these two together, I cover 80% of all application for sure. And if this is not good enough, I probably will use a triple stage filter, or what we think is more efficient, a high performance dual stage filter, as you can see here, which provides you a much better attenuation, especially at the lower frequency range. In the middle, it's also about 80 dB. It's not a 100 dB filter, but usually this is not required if you're not talking about special application like military application, test lab application, things like that. There you need 100 dB, or if you have, let's say, several motor drives, it might also be required, but then I would strongly recommend to go a bit deeper into and closer to the noise source and do filtering there instead of having just one big filter. It's just not cost efficient. As I said, the good thing is these two filters here, this dual stage filter, have exactly the same dimensions. When we talk about three-phase filters, three-phase filters is basically exactly the same as single phase. It's just for bigger power application and higher voltages. And of course, here we have also a wide range of 22 types. But voltage, as said, goes up to 760 volt AC and 2,500 amps. So that's really massive, big filters for energy applications. What you see here, of course, 1 up to 3 stage filters, 3 phases or 3 phases and neutral line. The typical machine filters look like the one on the right side, the FMBB EP, or we have also a DIN-rail filter, a bit the same as you have seen before on the single phase. The FPBB rail is a plastic housing filter to make it small and compact. Now, what is special here, or what kind of application trend do we see here? First of all, we made the same, as I said, slim housing for control cabinet. So it's a bit the same, plastic housing, compact filter. Here we have two versions. The difference is not that big, but we try to do a standard and a high performance version. It's still quite good when you look here in the frequency range here, starting on 10 kilohertz. I have to say here is 0. So it's not here 0. This is the 0 here on this graph is in the middle, but it goes up over 80 dB of attenuation. So you reach about 80 dB on the highest point here. And this comes because we have ferrite or nanocrystalline core material. So quite good performance for the compact size. As I said, it's little bit bigger than the single phase is 25 millimeter wide. Now this is 44 millimeter wide, so a bit bigger and also a bit higher. It has a metal ground plate here to connect to the DIN rail. And this one here has screw terminals instead of cage clamp terminals. Bit of technical data. And what else is a trend here? What we see, especially in Europe, is a trend to have machine made according machine safety standard, which is the IC standard 6204-1. Therefore, we made some filters to fulfill this standard, to make it easy for machine builders to fulfill also this application standard. So it's not required for the filters, but we made the filters to be according to the standards. And the filters that we have for this can be like FMBB or BDEP, look like this, compact shape, wide temperature range, small footprint, so it's quite short, made, and these are here double stage filters. Now, what's required according to the machine safety standard? First of all, if you have AC socket, it must be RCD protected. And the typical value for RCD protection is 30 milliamps. So whatever a ground current occurs about 30 milliamps, this RCD will trip off. This is basically human protection. Then another topic is whatever machine that is plugged in and you have a connector that you can pull out. So after 1 second, you should not have any voltage, touchable voltage on the connector pins of more than 60 volt. So that's basically just discharging of the capacitors in the filter within 1 second. And insulation resistance line to ground must be minimum 1 megaohm. So we are not allowed to use lower discharging or let's say bleed resistors in the filters. These are the main requirements, and the filters here, the machine safety filters, fulfill these requirements. What is also new is when you compare old generation of filters with new generation of filters. You can see here on top the old filter, 80 amp filter, 3-phase and neutral line filter. That is quite big and heavy, 5.7 kilograms. And the new generation that is shorter, it's about 1/3 smaller and about half of the weight. So that's also convenient for installation of filters in machines. It's always good to have a bit more space. So this is again a bit of technical data about the filters, what we talk about here, FMBC or FMBD, machine safety filters. And then of course we also have different style of filters, like compact filter, but only for up to 20 amp. So three-phase filters, very compact. And then single stage filters, which is the same, but a bit lower performance. In the standard range here, this compact version goes up to 230 amps, 520 volts. And this here, when you compare that, goes also up to 230 amps, up to 760 volt AC. So you have here also higher voltage versions available. For example, for 690 volt industrial mains network. Then when we talk about chokes, what we see over the years is that especially in energy applications, you see more and more compact designs because of new fast switching semiconductors. For example, gallium nitride is very compact and allows to have energy converter to be made. For example, years ago, a 35 kilowatts inverter used to be in a big rack, heavy with metal rack with chassis mounted filter. Nowadays, this is all made on a printed circuit board, and they don't have space for these big filters, and therefore they need common mode chokes, mainly common mode chokes on the printed circuit board. That's why we made over the years higher current common mode chokes. As you can see here on the left side, these are the typical, let's say, compact common mode chokes up to 10 amp. And then we introduced this kind horizontal or vertical style common mode choke up to 50 amp. And we even have a common mode choke up to 100 amp. So that's the difference, because the higher energy needs higher current common mode choke, all on PCB. I was a bit surprised over the year, you know, when we started, the demand of high current was increasingly going up and up and up. For example, we introduced 50 amps and we thought that's good enough, 50 amps. And then they said, no, we need 70 amps. So we made another series up to 100 amp. And nowadays, engineers tell us we need 150 amps on the printed circuit board. It's amazing what they do nowadays. Of course, we not only have a current compensated or common mode chokes, we also have linear storage chokes, saturation chokes, or ground line chokes. But that's more as a side note. What's special here? We have for all, let's say, all the new generation of chokes, we have ferrite or nanocrystalline core material available. We have SMD and DHD versions. A few also with wire leads are available. What is special, or what we can provide also, is evaluation boards for the new chokes, because we recommend for the customers, before you do the design, prepare yourself, do a filter on the evaluation board with one common mode choke, add some capacitors to it, prepare yourself, and then do EMC measurement. When maybe they can do it measure them by themselves, or they go to an EMC lab. It's good to have this on hand, because what the designers don't like is to change all the time the PCB design. So we recommend use evaluation board and do test as early as possible. Also, if customer wants, they can also do tests with simulations. We provide for all these jokes simulation models, SPICE models, that can be used in any SPICE simulation program, as you might have in your Altium Designer, or you can use LT SPICE for free. That's a good thing. These models are available on Schurter webpage for download for free. So this is just as a service. First do simulation, then build up your filter on an evaluation board, and then once it passes your EMC test, do the final design. This is a bit, as I said, higher integration of high power on printed circuit board. For example, think about that this is now done all in a sandwich, for example, very close. But this leads also to more EMC problems, as we see, because the components are not shielded from each other. This is one example of a new common mode joke that we made here. Of course, we have AC and DC rating for jokes, and it can be used here in this range. It has, for its compact size here, it has quite a high inductance. And then here you see also an overview of, let's say this is like the old style with the plastic housing, and then the newer style, or here on the left side, open type, that is a bit better for cooling, that you normally need. You need any kind of cooling when you have this kind of high power in compact dimension. So some sort of airflow or whatever is required here. Yeah, that's it about the winding goods and the EMC products. I think we have a few more minutes left for questions.
Yes, exactly. So, I'll share them on the screen, and feel free to answer them. Can you say it, please?
I need to switch here. I see here, can you explain how an EMC filter can amplify interference in a certain frequency band instead of suppressing it? Yes, this can happen. Good question. The reason for this is what you see in our graph, or when you think about the example I showed at the beginning of the presentation, the EMC measurement. Now, the impedance of this EMC measurement is always 50 ohms. But 50 ohms, this is according to standard, correct, but this is not reality. In the end application, you might see different impedance. And the worst thing here, and this is defined by the standard, is the complete impedance mismatch. That means, for example, I have on the input side a very low impedance, according to standard 0.1 ohm, and I have 100 ohm on my load side. Then I have the complete impedance mismatch. We measure filter with this mismatch, and what you see then is that the filter is not suppressing. There's no attenuation in a certain frequency range. It's typically about 10 kilohertz, 20, 30 kilohertz. So it's in the lower frequency range. It's not in the high frequency range. You see there's a gain. So the filter doesn't work. It actually amplifies or gains the interference. And that's the worst case. Now, we show this, and this is also written in the standard, that it is a good idea to show this, to be aware of this behavior. But of course, we cannot justify the impedance on the end application. You know, for example, if a customer builds an equipment or a machine, you don't know the electrical mains grid at the end customer where it's standing in a building. And this impedance can also change during the day, for example, depending on other loads on the mains grid. Therefore, this is like, let's say, it's not so clear. You just have to be aware of it. But there's not much you can do about it. But impedance mismatch is not good for the filter. It's the LC of the filter doesn't match with the impedance of line and load. That's the reason why you see that behavior. It's no topic for high frequency, but on the low frequency range only. Can you briefly, next question, briefly explain common mode and differential mode? That's quite simple. I mean, common mode, we also say asymmetrical measurement. This is line, for example, line and neutral with respect to ground. So I measure between line and neutral to ground. In common mode, I have in common noise on line and ground. Oh, sorry, on line and neutral to ground. What you can say as a general advice, as higher the frequency is, as more common mode noise we see. Reason for that is, as higher the frequency is, for example, above 30 megahertz, the noise is everywhere, in the field, in the air, everywhere. And then it is only with respect to ground. So the difference is between field on the conductor to ground. What software tools available? PCB EMC filter design. We have at least, let's say, we have recommended filter designs, for example, available on the evaluation board. This could be used as a guideline. Software tools, we don't provide. I mean, we work with Altium as a PCB design software, but we don't provide here tools. We used, for example, in the past, we had this, let's say, recommended PCB layout. But we see that this is not so needed anymore. I would say the guideline is here, the evaluation board. It's probably the best thing. Now, can Schurter offer filter which filters output from three-phase VFD? Output filters, we only have a few output filters. The thing here is with output filters for motor drives, we have basically what we have is a DU-DT filter. So DU means if you have this, let's say, fast rising, we have filters for that. What we don't have so much is sinus filters, things like that. And question about cheapest solution, how to compete with Chinese filters. Yeah, I mean, the Chinese also build good filters. But what you see here is a big difference in the quality from some supplier to another supplier. I would say the main argument about Schurter filter or other cheap Chinese filters is certification, service data like CAD models and all the things that we provide, and the product quality over the years. Because what we see from some suppliers is that it can be quite good in one series, but the next series is not so good anymore, especially when it comes to insulation material. This can be different. Cross-reference to EMC. Yeah, that's a good topic. What you probably know is that we have cross-references of filters, and what we often are asked now, can I replace one filter that has been tested and qualified for this application with another filter? Now, we often have to say, and I'm sorry for that, we have to say, yes, you can replace it, but you need to measure it again. And the reason is there is not 100% certainty that this is exactly the same. Even if, for example, one filter and the other filter, for example, the new filter, has exactly the same components, I would not guarantee that this leads to the same measurement results. That's really a tricky thing, and that's also one of the main reasons why a lot of customers don't want to change filters. If they even want to change, as written here, for example, they need a smaller dimension solution, then it's even more tricky. So there is no general advice or no guarantee that, let's say, the old, let's say, big filter can easily be replaced by a small, compact new filter, even if they are the same on the data sheet. For example, give you one example. For example, it can happen, and we see this also here in the EMC conferences, that old filters with a lot of massive ferrites are more robust frequency-wise, so over the wide frequency range, in real application than new filters made with more compact, with nanocrystalline core material, even if they are the same, equal on the test graph, according to standards. So that's just one example. So often it's not so simple. For a decade. Another level. Good point. That's, I mean, the mains filters are, let's say, the same over the years, over 20, 30 years, still the same. Basically, it's an LC. It would be good to have something complete new, but at the moment, I don't know what could be any component to replace, let's say, for example, the coil. Because the biggest component always is the common mode choke. And as you can imagine, this is quite expensive because the magnetic material, the copper, is all quite expensive. And it would be good to replace that. But at the moment, I don't see any material to replace this, let's say, traditional capacitors. What do you see if you look on 10 years technology? You see that the components, the capacitors, and the cores are becoming a bit smaller and smaller. You get higher capacities in the same size. You get higher inductance in the same size, but no significant change, really.
Okay, thank you. And we have one last question due to the time limit.
Yeah, that's also a good question. I can say any AC filter can technically be used for DC because for the filter works in kilo and megahertz. And 0 hertz or 50 hertz makes no difference for the filters. Of course, you have to consider leakage current and you have to consider the voltage. So AC, the peak voltage of AC is the same as the DC voltage. But be aware of approvals. If approval is required, we have some filters, AC filters, that are approved for AC voltage, to, for example, 277 volt AC and 400 volt DC, because this is equivalent.
Perfect. Okay, Herbert, so it's 11 o'clock, so our time is up. But thank you very much for a really enjoyable and interesting presentation. I'm sure that everyone who joined will leave with some really crucial and good information. I wish you a nice rest of the fair in Cologne. And yeah, as I mentioned, this recording will be available, and I hope to see and work with you in the future. So thank you again, Herbert.
Thank you, everybody, for your time. Thank you. It was a pleasure.
Bye. Have a nice day.